Good morning. We have a lot of people gone. They're at DECA, or they may be singing things that I were not able to do. So we're going to talk about exponential functions, and I think you guys are okay with e to the x, correct? So here's and I think I've shown you this proof already of proving that e to the x is its own derivative. I did implicit differentiation. I think I wrote dy dx here. Is that correct? In the proof. There was a while back, Austin, I was into y prime when I first started teaching. But the problem is my prime symbols look like ones, and students thought it was like to the first power. And so I moved it back to dy dx, but I'm too lazy to change my notes. So this is the same as dy dx. Are you guys okay with this proof? I think I've done it a couple of times. So we're just going to calculate some derivatives. And I will start with Landry. I just ask you to find the derivative, and you have e to the 2x minus 1. Okay, so you're going to invoke the famous chain rule. Do you remember this? Do you feel confident that you can give me an answer? Okay, so the derivative is what? And are you okay that I write it in green?
Yes.
Okay, because sometimes some people can't see green.
2 times e to the 2x minus 1.
Yeah, that exponent does not change, does it? You just multiply this function. We are guaranteed this function's in our derivative. Everybody agree with that? Savannah, you want me to give you a little hint on this baby? Okay, so the first thing I would do is I'm going to write x with an exponent, which is a negative 1. Are you okay where a negative 1 came from? Okay, because that's x in the denominator, and denominator means it's in the opposite. So if we take the derivative, what will we get? Well, we're guaranteed to have what? We're guaranteed to have e negative 3 to the x to the negative 1, right? Guaranteed to have that function. Now we're going to multiply that by what? And you might have said it already and I didn't hear you. Well, you're going to take a negative 1 times a negative 3. You're going to take this derivative, correct? So a negative 1 times a negative 3 is 3. And then x is going to be there, right? Because it's going to stay part of that derivative. And it's going to have a power of what? Negative 2. Very good. So now I can rewrite this. I could write this as 3 over x squared, correct? And then e to the negative 3 over x. So that would be my simplification. Owen, do you need a hint? Probably?
Yeah.
Okay. Are you okay that I write this as 1/2 e to the x minus 1/2 e to the negative x?
Yeah.
Yeah, you're okay with that? Okay. I find it very helpful to write the coefficients like that. Okay. So what would the derivative be of this first term?
Would just be 1/2 e to the x.
Yeah, it's like nothing happened. Because you're multiplying this by the derivative of x, which is 1. What happens here?
Is it plus 1/2 e to the x with a negative x?
Correct. And then if you wanted to, you could rewrite it like this. How was it to begin with? Right? I don't know if that's any better. Are we okay with those? Those are the hardest derivatives. Can I flip to the other side? My side's blank. So this is going in reverse. So we're taking the antiderivative. Well, the antiderivative of just plain old e to the x is e to the x plus c. Everybody okay with that? And I could take the derivative of this, the c would die, go back. So now if I and if you look, if I have this, let me write it like this, and I just write d of x. The derivative of x exists in that integral, doesn't it? And so when I reverse this, and when I reverse this, you end up, as long as this exists, you end up getting that as your answer. And if you notice, I could do u substitution. I say, okay, let u equal g of the x. That means if I take the derivative of both sides, I'm going to get the derivative of g. So this becomes, du becomes g prime of x dx. And so this whole thing is replaced by du, and then you end up getting this type of situation, which is this. I didn't know why I started the integral symbol. Am I kind of rambling on, or are we okay with that? All right, so let's take a look. Let me write this a little bit bigger. So, Sama, if I look at this, what's the derivative of this exponent? 3. It needs to be in here, doesn't it? So lo and behold, and I always put it by the dx, lo and behold, I'm going to put it there. But I have to compensate for it by multiplying by a third, because then I'm only multiplying by 1 and not changing any values. So my answer is going to be 1/3 e to the 3x plus 1 power plus c. I'll slide that over so everybody can see that. If you did u substitution, you could come over here and say u equals 3x plus 1. That's the exponent. Du dx is equal to 3. I don't have a 3 in there, so I have to write 1/3 du equals dx. And then when I substitute, I'll have 1/3 integral e to the u du, which would give me 1/3 e to the u plus c, and then I still move into that transition. Again, it's up to you. I think I did, oh, I erased it. I did a problem on the board for Ryan. I don't know, Ryan Burkhart, if anybody knows him. He's in BC Calc, and we were stuck. So when I get stuck, I go to u substitution, and it allows me to rewrite the problem and hopefully gain a different insight in solving, which it did in that case. All right, Aaron. Let me just write this here. How would you do this?
How would you do the u substitution?
Okay.
So u equals negative x squared.
Okay. So can I write du dx for you? And what would you get?
Negative 2x.
Negative 2x. And so what would you write next?
So du. And then
You're doing very well, by the way.
it'd be like negative.
You want negative here, negative here. So like a negative 1/2
Something like
equals x dx.
that. Yeah.
Okay. So here's your x dx right here. So can I write a negative 5/2 out front? Everybody okay where a negative 5/2 came from? And then this x dx becomes du. Are you in agreement with that, Aaron? Do not want to put words in your mouth, but, and then this becomes e to the u, because this gets replaced with that. Okay, and so you're going to have a negative 5 halves e, correct? Are you willing to replace the u right away? Yeah. Plus c. And some of you are still including this x. It gets removed by a negative 1/2 du. If I take the derivative of this, I'll have a negative 5 halves e to the negative x squared times a negative 2x, correct? And the negative 5 halves times the negative 2 will be 10 over 2, which is 5. Okay, so I check. I check if I take the derivative of this, will I get what I started with? Because this is a simplified derivative, correct? We doing okay? Elijah, you want me to give you a little hint?
Sure.
Okay, I'm going to do this. I think it's easier if you see those powers. Do you do u substitution?
Sure.
Okay. What are you going to let u be?
Is it x to the negative second?
It'll be always this exponent.
Oh, that one.
Yep.
So
Okay.
first.
The negative first. Okay. So that means du dx will be what?
Negative 1x to the negative second.
Which I have right here, correct?
Correct.
Okay, so I'm happy to see that. So do you see where I have a negative du equals x negative 2 power dx?
Yeah.
Okay? So I'm going to bring the negative because it's a constant out front. This becomes e to the u. And this whole thing right here that I'm underlining is going to be du. The negative du, the reason I bring it out front, Elijah, is sometimes I make mistakes. I think I'm subtracting du. Well, you're never subtracting du, you're multiplying, right? Because this is a width and this is a height of rectangles. So I bring out any constant out front. And then I multiply at the end. I'm less likely to make mistakes, I have found out, for Chuck Kruger if I do that. Okay? And there are other people that just write a negative du and they're perfectly okay. I just don't happen to be one of those people. So what's my final answer here? A negative e to what power? What was u?
U was x to the negative first.
Right, it's right here, correct? So I'm going to write it. Are you okay that I write it 1 over x?
Yeah.
Okay, and then r plus c. I think this is a tricky thing to see. And that's why I write it like this. And then sometimes I start trig substitution. I go, oh, here it is right here. And then I know I've got to have this in my answer because it doesn't disappear in the derivative, does it? The only thing that changes is what I'm multiplying by. Ooh, ooh, ooh. A tough one. Okay, Sophia, first of all, there's no plus c, correct? Okay, and I'm going to do this. y.
Oh,
Right, so if I'm thinking ln, what has to exist up here is the derivative of this thing, correct? Is the derivative of 1 plus e to the x simply e to the x? It is, isn't it? So I'm going to write the natural log of 1 plus e to the x. Would you agree with that, Sophia? And I'm going to substitute. Now here's another thing that I've noticed. The b goes in first, right? I think I wrote a few of your comments on there that you're switching them around, right? B goes in first, it's the antiderivative with b in it minus the antiderivative with a in it, which, you know, when TI made their calculator or Casio made their calculator, I really wished that's how you entered it on the machine, but it's not, right? It's the reverse. So what do I get here, Sophia? The natural log of what?
1 plus e to the first.
Yeah, which is just that, minus,
Natural log of, or 2.
1 plus 1, right? Which you said was 2,
Yep.
right? Because this is e to the 0. So I could write it this way. You don't have to, but you could write it this way. Right? Would everybody agree? Aren't you glad we already talked about E? It made it nice. So we're done.